Um, Before starting, I would like to welcome everyone that has joined in these 2 minutes for today's webinar that talks about antenna design and optimization with CST Studio Suite on the cloud. My name is Basma Ben Zamia, and I'll be your host for today's session. In this session, we will explore the newest capabilities of CST Studio Suite and how it can help you perform electromagnetic simulation and how to manage the full antenna design and optimization process step by step. I'm pleased to introduce our speaker, Mohammed Zourab. He's a solution consultant for electromagnetics simulation here at LaunchTech. Mohammed holds a bachelor's degree in electrical engineering and an MBA, and brings extensive expertise in electromagnetic simulation using CST Studio Suite, particularly within the aerospace and defense industry, as well as high-tech sector. I would also like to take a few minutes to introduce LaunchTech before we deep dive into the technicalities and the demonstrations of the software. We are a software organization specialized in software reselling. We do also consultancy services and software training. We leverage the latest technologies to provide for our customers and our collaborators comprehensive solutions in product lifecycle management, design, simulation, and manufacturing. We support the whole Middle East and Pakistan, and we are the only gold partner in the region for Dassault systems. And through this partnership, we ensure to provide software tools to our clients and collaborators to enhance productivity and product quality and ensure innovation. For today's webinar, we will be focusing on four main parts. First of all, we will introduce you to the terminologies and concepts of electromagnetics simulation. We would also introduce you to the portfolio of software that we provide, and then the heart and the core of today's session, which is the demonstration on the step-by-step demonstration of antenna design and optimization, and obviously at the end the Q&A session. I will give the floor to my colleague Mohammed, and
Yeah, thank you
I
very
hope you
much,
can
Vesma.
share your
Yeah.
screen.
Um, yeah, okay. So I think you should be able to see my screen.
Yes.
Yeah, thank you again, Basma, and thank you everyone for joining us today. Hamad here, and I'll be taking over to show you, to cover the rest of the technical aspects of the webinar. Now, I wanted to start off by giving some terminologies and concepts of this webinar. So we're talking here about CST Studio Suite when it comes to the cloud. And the cloud for Dassault systems is done through the 3D Experience platform. So first of all, for anyone that has not experienced or worked with CST before, let me tell you what is CST Studio Suite. So CST Studio Suite is an electromagnetic simulation suite that solves or runs jobs for applications from low frequency up to high frequency and radio frequency, as well as physical light and particle dynamics. So, but we're not going to go into all of these, different disciplines of CST. You can see the main ones here in the screen. I'm going to focus more on what most of our customers in the region use the tool for. And now one of the, the main or top usages of CST is for antenna design. So this would include developing your antennas, optimizing them, running their simulations, understanding their behavior, inputting it or including the antenna with a radium, or building antenna arrays as well, all of which can be done within the software itself. Now, another thing is putting the antenna within the context of its environment. So antenna installation. You don't only want to see how the antenna behaves by itself, but of course within the context. If it's whether it's in a phone or on a plane and so on. So this is another topic that CST can handle, and a lot of our clients use the tool for, as well as certification. So when it comes to electronics, human beings, you always want to make sure that your devices adhere to the regulations, FCC standards, and CST is used by the biggest companies developing phones, including Apple, Google, Samsung, to make sure that it adheres to these certifications and standards. For instance, here, the main parameter would be the surface absorption rate for humans. And lastly, and one of the the most heated topics recently is radar cross section. So people want to understand the footprint of their if their airplane or UAV when it comes to radars and how to mitigate it. And in instances, how to develop metamaterials, including FSS and RAM materials, and including them or coating their model with it so they can see the differences or how it's mitigating that cross section. Now, with that said, this is, in a nutshell, what CST is. CST is a tool that allows you to develop, simulate, and optimize and improve your design processes. Now, another topic of discussion is also the cloud or the 3D Experience platform. So the 3D Experience platform is a tool established by Dassault Systems for a complete end-to-end process with engineering and business aspects. So this includes complete product lifecycle management of your products from the very initial conception and design, project management, and up till engineering design, simulation, and manufacturing. So it includes that complete process in a unified environment with a unified or with multiple stakeholders in an effort to save time and standardize processes. And from what you see here on the right side, these would be the typical um, fabricated tools that you would use, not including as well the engineering tools that you would use from CAD and simulation manufacturing. And the 3D experience aims to have that complete set of platform that covers it from the beginning to the end. And now you may be asking a few questions of the cases where this would be useful or instances where this would be most valued. Now, to give you an example, in typical practice, you would have your designers and analysts working on product development where they would be sending these data by files between them each other. And a lot of time, this would lead to a lot of errors. So maybe an analyst does not have the latest version of the part or an assembly. That assembly maybe is pushed to manufacturing by mistake because it's not the last variant. Instances of change management and their execution become very hectic. So this process where a group of multiple users from teams at different departments maybe would be using different tools to adhere for a single problem usually would take days because of this. So what the 3D experience offers is a unified environment where now everyone would be working in a unified environment with a unified database so that we know that the version we're working on is the last version. So you would have complete history and version control, understand the history, how it became to be, and where it's supposed to go next. And this is what we call a data-driven and approach and a model-based design approach. So this is in a nutshell what are the terminologies and concepts that I wanted to introduce here before we start, with discussing more about the electromagnetics on the cloud. Now, with that said, I'm going to move now next to what Dassault Systems offers in its electromagnetics portfolio. And just before this, I have a poll because I want to know who in the audience here today have experience of or worked with electromagnetics or CST before. You should see a poll in the screen from your side, and we'd be very thankful if you can participate. Give us what is your background, where you're coming from. Yeah, it's going on now.
Yes, let us leave a few seconds for everyone to participate. Yeah, I think 56% are not familiar with the tool. and the rest of 22% are somewhat familiar, heard of it, and the other
Okay.
22% are very familiar with it. So I think we have a
Uh,
mix of.
yeah. Okay. Great. Now, for anyone that have not experienced CST before, it's a great session for you because we're going to start from the very beginning till the end. But you will also understand the new concepts or the new usages of the CST software with the cloud. For everyone else that have used it or experienced it before, you're also in for a treat because we're going to show you new things about the portfolio and the new additions that, for me personally, I found very interesting. Now, with that said, let me give you an idea of how the portfolio, the ergonomics of the portfolio stand as of right now. So we have, for anyone that used the software before, we have the legacy CST Studio Suite. So this is the desktop app that you install into your machine and you license offline into your network. And whenever you want to run a simulation, you would run it within your machine itself, right? So this is very typical, like any other software that you would find in terms of simulations in the market. Now, what we have is we have 3D experience, and now we want to connect this CST or this app to the 3D experience. Multiple reasons, one of which would be the centralized data center, so you can have access to all of the data base of your company, for example, including your CADs and structural analysts and other teams. And what we provide is we provide now a connector. So this is a different license other than the actual CST license that would connect your CST with the 3D Experience platform on the cloud. Now, you would ask, maybe this still does not make sense to you. It starts making sense the moment you see that you can do cloud computing on the 3D Experience platform. So a lot of times you do not have that hardware to complement your software. You're working with very big problems, big bandwidths, and you just simply do not have the hardware. And you want to you would wish to have an access to some sort of maybe an HPC, but it's HPC now we're talking about a bit of overhead cost that comes with it. So the 3D Experience platform would give you access to cloud computing. We're going to know more about the configurations of the code that we have on the cloud, but you would ideally be connecting it for that centralized data base as well as the cloud computing. So now with this configuration, we have figured, or Dassault Systems, as the strategy is figured that maybe we can group everything into a single unified license. So, and that's where the electromagnetics engineer comes in. So the electromagnetics engineer has what's good, what we know from CST, including the desktop app, and the ability for you to run local computational jobs, but also allows you to automatically have a connection with the cloud by default natively, so that you can run jobs on the cloud. But not only that, unlike the traditional license where you need to account for tokens for your jobs. So whenever you run a job, you need to have a number of tokens so that you'll be able to run the job. This would have an embedded compute system. So there's a number of cores that you can use by default without any additional cost. We're going to know more about these configurations and the embedded compute in a minute. And then lastly and most interestingly, you will be able to use the browser interface of CST Studio Suite. So this is now you can access CST from your browser itself. You don't need to even install it in your machine. And yeah, so I'm covering here again with more details what I mean. So desktop app and browser. So the older typical CST license, you would see this desktop app. The, the new electromagnetics engineer has the desktop app plus the browser. So you can see here, this is CST open in the browser itself. This makes it very nice because not everyone has on the spot CST installed in their machine. You don't need to spend time to install it. You can just open it like that from your browser. Maybe you want to open it from your tablet. Maybe you're not using a supported operating system. Maybe you're using, instead of Windows, you're using Mac, for example. So this makes it very easy for all of these usages that were not that users typically would not be able to do this before. Another thing is the ability for cloud computing. So cloud computing, including embedded computing, what you see here are the configurations or the hardware configurations that you would be able to run your jobs on the cloud. So Dassault Systems has these on the cloud embedded with the 3D Experience platform, as you can see, using latest state-of-the-art CPU types, as well as extremely high RAM configurations compared to cores. These high RAM configurations you would not even find in normal workstations typically. And then if you ever want to use a GPU or hardware acceleration, you're looking at the best in class, more or less, from NVIDIA. So the idea behind Electromagnetics Engineer is that by default, you will be able to use the, the 16 cores configuration and embedded configuration. So this is something that you do not need to get anything or pay anything more for apart from getting the Electromagnetics Engineer role license itself. And then if you want to increase your configuration, you will have to get adequate tokens. Now, another topic that we discussed already is the unified environment and database. So what does that mean? So 3D Experience platform is actually, it's a platform that's used by many of the big manufacturer and designers and structural analysts in the world. So you would expect a very big company when they were working, for example, if we're looking at Airbus, we have very big assemblies that we have in the platform. And these big assemblies, of course, require something like a high-end CAD software like CATIA, and this is CATIA on 3D Experience itself. What is nice about this connection with the 3D Experience platform, you can simply import these models into your CST environment to run a bit of a complex kind of scenario here. But also it would include all of the history and the model itself will be completely parameterized with whatever you have set up already in CATIA. And you can run the simulation locally or on the cloud or set it up in your CST environment. Then you can visualize the results on the 3D Experience platform. So this is another thing that is, if you have already a kind of a system in place, it will be very useful to just plug in and connect to that system like that with your CST license. Um, the last thing about the electromagnetics engineer role is that it is licensed by the cloud. What does that mean? It means that you don't need to be in the network of your company to access the license. You can access it with only an internet connection. So um, sometimes we'd have an issue where something happens in the network of the company and then you would not be able to access it. Maybe you've went abroad or something and you're not able to access it. So here what you need to do is have that internet connection and you'll be able to view CST from your browser or from your local desktop. Now, with that said, I have covered here the portfolio and gave a glimpse or focus on the electromagnetics engineer role to give you an idea of what is new in this new license. The next section of this webinar will be going into our demo. So here, what I have for you is a patch antenna, and the frequency we have 3 gigahertz. We're gonna design this antenna in CST, and then we're gonna run some optimizations to get adequate results for what we need. For reference, our design parameters are on the screen here. For reference, the substrate material we're using is the Rogers TIM 3. If you want this as a reference. And then here next, I'm gonna go to our workflow. So I have 6 steps that I will go through from launching CST until having the final model after it's optimized. Now let's go together into step 1. Okay, so this is what you see here is the browser interface of the 3D Experience platform. This is the PLM system that everyone will be able to connect to. And simply what I'm going to do here is I'm just going to open my toolbar and I'm going to look for the electromagnetics engineer role. I'll click on my engineer role and then I will click on CST. So as you can see here, I have 2 applications, CST Studio Suite connected, which is the desktop app, and I have CST Studio Suite Cloud connected, which is the browser interface. So once clicked, CST itself will load from your machine itself. And this is the interface. For anyone that's used CST, they will notice this right away. So this is the usual typical interface that you work with. Now, Next step here includes to complete the model and prep the simulation for simulation. So once that we have established and opened this, once again, for anyone that's already used the software, we already know this. For anyone new, what we need to focus on here are basically these two options. So the first option on top is what would allow you to connect to the 3D Scenes platform. If you want to fetch a model from there or upload a model, you can simply do it from here. But what's more importantly here is our template. So CST has these templates that are based on the different disciplines it serves. And these templates are very useful because they more or less set a lot of things for your simulation. So kind of make it much easier for you to start your simulation. These are and things like, for example, boundary conditions will be automatically set in a ratio with the wavelength depending on the type of antenna you're working with. I'm going to skip here. Okay, so once we click here, and once again, we can see all the different disciplines in CSC. We are today working on microwave and RF, so we'll choose this option. And then we are working on antennas. We'll choose antennas, click next. And then you can see here the different antennas that we can, just build this template of. And then we choose planar because we have a patch antenna today. Now, one thing that I should mention is that CST has more than 21 different solvers, including time domain, frequency domain, integral based, asymptotic based, as well as structural based, CFD based, as well as thermal based. So for the nice thing about these templates, given the big number of solvers that they have, it will decide for me what is the best solver for my application. So for here, I can work with the time domain or frequency domain or multi-layer. A time domain for a wideband, frequency for a resonant antenna based, or multi-layer for infinite dielectrics and ground planes. I'm just going to stick here to the time domain um, to keep it simple. And then I need to set up my units, which all of my, the entire project will depend on these units. And then here, I just need to set up my defined frequency and the monitors of interest. So I'm just going to skip here a little bit. So as you can see, my frequency is between 2.7 to 3.3, but it's defined at 3 itself. And then this is your template. You can name it whatever you wish. It's good to name it based on the application, so we can always come back to it if we have a similar application. Once that's done, I'm now introduced into the user interface of the application. Now, CST has one of the more intuitive user interfaces, and you can see it in a minute now. But what I want to highlight here is the upper ribbon. So the upper ribbon here is done in a sequential way. So I have in home here more of the most important options of my software. But here you can see modeling, simulation, and post-processing done in sequential way because that's the expected kind of sequence. So modeling here, I can look into my materials. I can look into my import and export options, create shapes, and so on. For simulation, these are my ports, my simulation optimizer, my solver setup, optimizer, parameter sweep, and mesh. Post-processing is for post-processing related templates. Now, on the left side, I also have my navigation tree, which hosts all of the content related to my part and project. My results and parameter list at the bottom, as well as my messages and progress. Now, the nice thing is, what you see here is the quick start guide. So this is the guide that will help you identify what are you missing up till the point where you are good to go to run the simulation. So here, we already picked up the time domain. So we're just gonna click next. And as you can see here, these are the different steps that you can CSC is expecting from you before you run your analysis. You can see here, last point is start solver, then analyze results. So the main thing here is that, as I said, the template already defined a few things for me, but I can, the next step for me would be to define the structure. Frequency is actually already set. It will be recognized after the structure is defined. Set up my excitations, monitors are already done, and then after that I can start my solver. So once again, I'm doing here a patch antenna, and I'm going to define the materials before I start. On the left, you can see these are my materials by default: PEC, and vacuum will be the default in CST. But I'm going to go to modeling and define a new material. So you can define different types of materials in CST. There's actually extensive library in CST as well. If you want to fetch a material, but there's a lot of options that allows you to define a lot of parameters for materials. So this is my substrate material, and I'm going to do my permittivity here, 3 point, I think it was 27, 3.27. Yeah. And then I'm also going to set up my conductivity. My electric conductivity, I'm giving it a tangent delta of 0.002 at 3 gigahertz. Yeah. And that's it for my substrate. So here you can see my substrate is created and added to my project library. I'm going to create a quick other material here for my coaxial cable. So one thing I forgot to mention is it's a pin-fed circular antenna. So it's going to be a pin or coaxial pin at the back of the antenna to feed the source. So my epsilon here, I'm going to keep it at 1, and this is a simple material just for my coaxial connector. Now, once that's done, I need to now to define my structure itself. So the first thing to define is the ground plane. That's my ground. And CST allows you to input your modeling from an XYZ minimum and maximum perspective. So this is my first part. It's a ground plane. And what I'm going to do here is I'm going to start by instantly adding my parameters. So you've noticed I haven't defined any parameters, but I just started by instantly inputting them into my brick configuration here. So as you can see, I have my ground plane over 2 in both directions, X and Y. And then I'm going to do my height in the Z max option. That's my ground plane height. My component is going to be basically my assembly name. So I'm going to name it here an antenna. And my material is going to be a PEC, perfectly electric conducting material, because that's on my ground. It could be, in typical practice, it could be copper. So here now, because CST recognizes that these are parameters that are not included in my parameter list. So it asks me, the moment I try to create this, what value do I want to assign to each of these parameters? Very neat for CST. And I can define now my ground plane width and height. Once I'm done that, this is my ground plane. So another thing that is very neat in CST is that you can define a new coordinate system. So what you see here is I define a new coordinate system based on the surface of my ground plane. So this will become my new 0, 0, 0. And off of that, I can replicate the same step I just did for my substrate. So everything will be the same apart from my height will be substrate height, which is the new height. And then my material will be a substrate as well. Of course, substrate height is not added to my parameter list, so it's going to ask me to define it before creating. And this is my substrate. So the same process is repeated for my patch. And then once I'm done with the patch, I start working on the coaxial pin. I'm just going to accelerate this. So what's worth mentioning here is that I have a coaxial pin connected with an offset of 2.75. And it is surrounded by PEC material. Here you go. Yes. So this is now my complete setup. Just double checking here in this part to make sure that my coaxial dialect is starting from the ground plane, and my coaxial cover, PEC cover, is not. Okay. So now, with that said, if you look at the quick guide here, so I've defined my structure. It recognized my frequency. Boundary conditions are already set up by my template. And then what I need to do next is to define excitations. So I'm going to use a waveguide pin, waveguide input here into my coaxial cable. Yeah, so waveguide port. And once again, because I've started my template based on a planar patch antenna, I don't need to define anything else in my waveguide port settings. And then once again, you see on the right side, excitation done. I just need to start my solver. Of course, I'm gonna do some checkups before I finish here. So I need to check my mesh. See, we have 240,000 cells. I can also check up my solver settings. So I need a normalized 50 ohms impedance, input impedance, and then my cutoff accuracy of my solver as negative 50 dB. Now, with that said, I am set and good to go. As I said, I can run the simulation locally, or I can run it on the cloud. And I explore one thing here in terms of the acceleration by the end. The settings, acceleration, I can see that I can run up to 16 physical cores on my device, and that none of my tokens, none of my 40 tokens are required. So 0 tokens are required because it's an embedded license. So this is just a checkup. I'm not going to run it on locally. I'm going to send it to the cloud in my next part. Sorry. Yeah. So here, remember this option for the 3D Experience platform. So I'm going to save this model into the 3D Experience platform. Just need to make a local copy first, and then it connects now to the 3D Experience platform. So once connected to the 3D Experience platform, you're going to notice it's going to ask me what is the name of this analysis and what do I need or what do I want to import into the platform. And with that, I will see connected to the 3D Experience platform. So now officially my part is synced with the cloud. I'm going to go to the cloud right now. So I'm going back to my browser. To run this analysis, I need my simulation manager application. So I'm going to look for my simulation manager application. Here you go. And so the simulation manager application is actually an app that can run any sort of analysis in your platform, structural CFD or any other sort of application. So you can see all of your different cases of analysis in a single place, as you can see here. So this is my patch antenna radar 3 gigahertz, which is what I just created. And this is sort of the interface you can expect. It's a high frequency simulation. And for me to start the analysis, I just need to click onto my start icon here in top right. And once again, so you see here, I have 40 available tokens. I am running this version of CST. It's only a single solver, and the configuration by default is 16 cores. Now, I'm not going to go for 16 cores. I'm going to go for 32 cores and about half a terabyte of RAM. Yeah, and click on run. With that, your simulation would start on the 3D Experience platform, Cloud Compute, and you will just wait until it's done. So a couple of seconds later, this is your part or your analysis finalized. The nice thing is that you can still view some of your results in the cloud itself. So before starting, you can see, before even opening CST itself, you can see, for example, that this is my S parameters here. So it's not perfect. I'm not hitting the negative 10 dB, and I'm not at 3 gigahertz, but that's fine. We can optimize that. And here, so notice here what I did. I can open my analysis, which I just ran. Right-click, open with CST Studio Suite. Now, and this will open for me CST on the browser itself. So I want to just visualize a few of my results, maybe set up my optimizer. But I want to mention that this is the complete CST environment. So I could have done everything I've done so far in this same environment. So once again, I can view my results here. And I can see my far field, for example. my directivity, and gain about what's expected. And yeah, so with that said, I visualize my results, I run on the cloud, and visualize the results in the cloud itself. Now, what's next is very intriguing. This is my optimization setup. So the optimizer in CST is very simple. You can just base it off on the parameters that you have, which is why having a parameterized model is extremely important. So in the optimizer here, I can set up the parameter that I want to change for my goal. So here I'm going to do my patch diameter. And then I'll go to my goal tab here and add a new goal. That goal will be based on the S parameter result template, a magnitude, and I'm moving my minimum. So the minimum in my graph will be moved to 3. Click on OK. OK, and then just save my model again. Yep, and then that's it. So I close my CST and I can go back to my simulation manager. And I will go back to the same simulation. And run it again, but this time I'm going to configure it to run for the optimizer. So single solver to optimizer. And once again, I can choose my configuration. So with that, I'll get to my last point. So the last point would be with the last model. Once that simulation is done and completed, I can open again my model in CST on the cloud on the browser itself, and I can look into my S parameters. So here you go. It's still not the best in terms of dB, which is why I wasn't satisfied enough with this. And I did another optimization. So I have right now I'm opening this live for you. This is my session. And I had another run with my optimizer where I set basically I set my ground plane as well into the equation and as well as my offset with the patch diameter. So and I set up a new goal with S parameters. My operator is to minimize or to put my S value or magnitude below 10 dB. And I ran that again in the cloud, and I got this expected behavior or expected S or scattering parameters. And yeah, again, there's a slight increase in my gain, which is good. And of course, you can view a lot of different information, including your power output. So you can see that most of my stimulated power was actually accepted, which is good. I can see my electric field distribution here as a contour or as arrows, so you can better understand. This is good to understand kind of the behavior of the electromagnetic waves into your system. Now, go back to the presentation. So with that said, we have we finalized the complete loop where we modeled, simulated, then optimized our model for the best output. Now, CSC, of course, is not only about this. This is typically the smaller portion of the job, because, like I said, sometimes you need to explain or to explore more things, or let's say go to the next step of development. So with that said, you can actually, what you can do is just go next. Yes, sorry. Yeah. So you can take it up a notch and you can build your antenna array of a CST. CST can build your antenna array in a matter of few minutes, and you can achieve a higher directivity, for example. And it uses the array task implementation, where you can just set up your X and Y, basically sizing, spacing, passive and active elements, and it will do it there for you. And then you can also see the different scan angles if you have any blind spots in your configuration, how to go out without it. Now you can also take it up a notch and you can install antennas onto your system. So you can, if you have a model, or airplane or a car or anything, you can install your antenna to see how it behaves in the context of that model, and if there's any um, issues that will arise from that model. But not also that, you can also have multiple antennas in your model with different receivers and transmitters, and build a violation matrix where you can see if there's going to be any interference between any transmitters or receivers. Another very interesting topic is radar cross section. So you can not only run your monostatic and biostatic RCS, but it's nice that you can develop metamaterials like frequency selective surfaces or radar absorbent materials, RAM, in CST itself, see how they behave with frequencies, apply them into your model as you can see here, and then achieve reductions in the RCS. So as you can see, the applications more or less are limitless, and for CST, the sky is the limit. Unlike any other software, you do not need to get any configured packaging, or you don't need to get multiple licenses to do all of these different applications. It's just one license that hosts almost all of these. Now, with that said, I'm done with my technical presentation at this point. I think Basma, I'll send it over to you once again to see if you have any questions and to see how can people get this tool.
Amazing. Thank you very much for your presentation. Before jumping to the Q&A session, I would like to take few moments to discuss how the viewers can access the tool. CST is paid. However, we provide very competitive prices to different groups. If you are an academic researcher or an academic student or teacher, we provide the license on unlimited cloud access as well as free certification with it, since this is very important for students, and free online training, because this is also very important for students and teachers. We do provide it at a very suitable price, taking into consideration the teachers and the researchers, the academia researchers. If you are part of a startup and you would like to innovate and take advantage of the tool in your business, we also provide annual discounts for you, specifically for startups, with obviously complementary business tools that lets you manage your engineering processes. And in general, if you are a new user to the tool, we also do support you with starter and new user prices. Feel free to drop us an inquiry at our email or our number. And finally, we have reached the final section, which is the Q&A session. Feel free to drop any of your questions in the Q&A box. Um, I have a few questions for now. Um, I have already CST. How can I use cloud compute?
Okay, perfect. So that's a good question, and this is something that we get a lot, because you've already invested into a license of CSC. So how can you get access to that cloud compute? Like I mentioned during the presentation, there is a license called All Physics Analyst that allows you to connect your setup or your CSC setup into the cloud, and from there you will be able to access the cloud configurations to run your analysis based on the tokens that you would have.
Mhm. What is the minimum core I can run in the electromagnetics engineer without additional costs?
Okay, so another good question. One of the things that are good with the electromagnetics package or the electromagnetics role in the 3D platform, you can run up till 16 cores, 16 physical cores without any additional cost. So that's already included into your license configuration.
Mhm. Okay, perfect. There is another question. Uh, it's more related to the 3D experience. What makes the 3D experience different compared to the other tools like Microsoft projects?
Yeah, I guess this is from the business aspect. So from the business aspect, something like Microsoft Project can run projects, but unfortunately, it can only run projects. So the 3D Experience platform is not only a tool for engineers, but also for the business aspect. So you can run projects with your tasks, milestones, and you can connect these tasks with models from the engineering departments and validation steps with root approvals as well. So this means that you can have your engineering and business in a single platform, both of them communicating easily together.
Mhm. Okay. We have also several questions regarding the recording. Yes, rest assured, the recording will be shared with you after the webinar on email. And we reached the end of our webinar. I hope everyone found the webinar helpful and you learned something new. If you have any inquiries, reach out to us. We would love to have meaningful discussions on the technology. Thank you very much, everyone.
Right? Thank you.